Okay. Good morning to one and all. In the previous lecture, we have completed the unit number second. That means physical principle of sensing element. In the all basic term we have covered. Okay. So today, today we will discuss about the next one unit. Sagar. Today we will discuss about the next one unit. That is unit number 3. Interface electronic circuits. Okay, so while using the sensor for any one of the system, that block diagram we have already discussed in the first lecture. So sensor is the part of one complex system, or it is one of the element of complex system. In that, it will require some of the different electronic circuit, right? Different electronic circuit will require. So we want to understand that electronic circuitry. Again, this is related to basic. So interface electronic circuitry. Unit content of this unit is that so input characteristics of interface circuits. So these are the unit content of this unit. Content, unit content, input characteristics of interface circuit, right? So we have discussed regarding characteristics, each and every sensor charge, which are the characteristics we have discussed. So input characteristics of interface circuit, it is nothing but output characteristics of sensor. लक्ष देता इंटरफेसिंग सर्किट कुठे यूज करतोय आपण सेन्सर जो आहे तो ज्यावेळेस आपण मायक्रो कंट्रोलरला किंवा कॉम्प्युटरला कनेक्ट करतोय in between that we are connecting interface circuit, right? So if we understand the input characteristics of interface circuit cha input characteristics means output characteristics of sensor, right? So here it is suppose sensor, it's sensor either its output whether it is in the form of analog, we require analog to digital converter, A to D converter. So it is one of the electronic circuitry, right? Depends upon output of the sensor. Depends upon output of the sensor. We are using that interface circuitry. That means if we understand the input characteristics of interface circuit, it is nothing but output characteristics of sensor, right? So input.
Good morning, everyone. We are here from CSE department. We have organized an event which is tomorrow, that is Spirit 2K22. The timing for the event will be from 9 a.m. to 5 p.m. There are total 6 events. First one is the virtual campus drive.
And virtual campus drive is also divided into 3 parts, like the actual campus drive. there are three parts. First is aptitude, second is technical, which is also called as pseudo, and third is HR interview, which will be taken by actual company HR and team members. So please participate in the virtual campus.
The next event is the quiz competition. In quiz competition, there will be questions based on general knowledge, current affairs, and Bollywood, Hollywood type of questions. There will be no technical questions, so you can participate in it and enjoy it.
The next one is programmer. In this you can participate. There are two rounds, and in each round there are two problem statements. You can choose multiple languages like C, C++, Java, Python. In this programmer, you have given two problem statements. So the fastest coder will be the winner.
The next event is Funzo. Funzo is a game zone. There will be multiple games. You have to participate in a team of 4 members. The registration fee for Funzo is 250 for each.
And the next game is Hunt Down. It's a treasure hunt, but technical kind of treasure hunt. You guys can participate in it by scanning the QR code, and you will find all the details in it. And if you have any query, the event coordinator number is there. You can contact.
Next round, the next event is BGM. All of us know. Just scan the QR code and you will get the all details about BGM. And please participate in BGM.
Guys, if you want to enjoy the event, you can participate in Funzo and Hunt Down BGM.
And the entry fees for technical and non-technical event is each member 50 rupees.
If you are really serious about study, please participate in technical rounds. It will be helpful for your campus life also.
Any questions? Certificates will be provided for participation as well as for winners and runner-up. There will be cash prizes for all the events. All the events.
Anything else? Anything else?
Interviews will be also online.
Yes, you can experience the actual placement, how companies are conducting the placements. You can experience in virtual. Any question?
You can scan the QR code. There is a Google form. All the rules, details of the coordinators are given. If you have any query, you can contact them.
Just scan and
Register
register.
today before 6 p.m. Event is tomorrow. Thanks.
Thank you, sir.
Okay, see, unit content of this unit is the input characteristics of interface circuit. We want to understand the input characteristics of interface circuit. So depends upon output of the sensor. Depends upon output of the sensor. We are interfacing electronic circuitry depending upon output. If the output of the sensor it is in the form of voltage, suppose we are voltage it is in the form of low level signal, so we are using some of the amplifier, some of the electronic circuitry to interface that. Depends upon output of sensor. Sensor चे output असेल, so depends upon that output we are interfacing some of the circuitry. So we want to understand input characteristics of interface circuit. Right? Input characteristics of interface circuit. Second one is that unit content amplifier. You people already know amplifier. If the signal obtained from the sensor it is the low level signal, then we want to convert that signal into a high level, right? So that we require the amplifier. So we want to understand the amplifier. Again, excitation circuit. Some sensor it will be required some of the excitation circuit. So excitation circuit is there. Another one, analog to digital converter. That means to convert computer readable form or computer readable data. You stand up, all three. Why you are sitting like this? Stand up. Just stand up, all three. See, analog to digital converter, that is A to D converter, analog to digital converter. So to convert the computer readable data from signal obtained from the sensor, we require analog to digital converter, right? Then direct digitization and processing. So how digitization it can be done. I think in control system, there is a digitization process of signal system. There is a digitization process. Analog signal it can be converted into digital. Before converting digital, we want to convert it into sampling form. म्हणजे sampling मध्ये convert केला जातो अगोदर. After converting into sampling, it is converted into digital form. So we can call it as a Laplace domain. It can be converted into Z domain. Z transform मध्ये convert करतो. So digitization and some of the processing of digitization. Then bridge circuit. So bridge circuit it is also electronic circuitry. We want to understand different types of bridge like Stone's bridge or other type of bridge. Then data transmission, how the data it can be transferred. So we want to understand the data transmission and let's say about last one point is that batteries for low power sensor. So which types of battery it can be used for low power sensor. So battery it is used as a excitation for a low power sensor. Okay, so we will discuss each and every point in details. So see, first of all we will understand the sensing model, how it can be sensed, and we will understand again the all the unit content of this unit number 3, interface electronic circuitry. So this is the actual sensing model, similar to that of our block diagram of sensor, right? So there are some of the electronic circuitry in the block diagram, not more electronic circuitry it can be shown. We have shown only interface, right? So in here, how it can be interface. So there are some element it may required for interfacing the sensor to the microcontroller or it may be computer. Interfacing setting. There are some of the device it can be required. So here it can be given stimulus. That means one sensor it will be sense some of the stimulus. So support system for that, it is required some of the support system for that. Stimulus why? It is nothing but stimulus is nothing but another one object. We want to send that object. So again support system required for that, right? Support system it can be required. Then which is the sensing element? त्याच्यामध्ये sensing element कोणता आहे? To sense the X or to sense the X stimulus or it may be object. Which are the sensing element to sense that Y object or Y stimulus? Again, conditioning of the signal. So signal conditioning it is very important while interfacing it. So signal obtained in the form of output voltage, signal obtained in the form of output current, signal obtained in the form of amplitude or it may be phase or it may be frequency, right? Signal कोणत्या फॉर्म मध्ये obtain होतोय त्याच्यावरती डिपेंड राहील. Again, whether it is low level signal or it may be high level signal, whether we want to need to convert it to high level, so that required amplifier, whether this signal is analog signal, digital signal or it may be sampled signal or direct digital signal. So signal conditioning or signal conditioner it is very important part in this sensing model, right? After that we require multiplexer. So multiple input we are connecting and it will work at a time one output or it will use one output at a time. Again there are analog to digital converter it can be required. That means microcontroller or it may be our computer system it will be able to read the digital data only in the 0 and 1 format, so that we require analog to digital converter, right? Analog to digital converter it can be required. There is processor in nothing but microcontroller, and to store that data we require memory also, okay? And there is a communication. So communication channel, this data it can be transferred. Again the communication channel is there and it is shown in the peripheral devices. And at the same time, according to our block diagram, after peripheral device displaying that microcontroller or processor, it will send one signal to actuate in automatic system to as an actuator to do the function which stimulus it can be sensed and what is the problem. This resolved by using that control system and by using actuator. Okay. So at the same time there is a display in the peripheral device. Peripheral device मध्ये काही display, right? So this is the sensing model. In that sensing model, the signal conditioning, it is very important point. Signal conditioner, it is one of the most important part. You see, signal conditioner, it serves as some purpose to bring the signal from the sensing element up to the format that is compatible with the load device, typically an analog to digital converter. So what is the importance of that signal conditioner? Or it serves as a function or purpose is that to bring the signal from the sensing element. So sensing element किंवा sensor आहे, त्याला sense केलेला signal काय करायचा bring. To bring the signal from the sensing element up to format which is compatible with the load device. Load device का जो काय format compatible असेल, so load device is nothing but up to analog to digital converter. Okay, so we require the compatible signal. So this signal can be carried or bring by using the signal conditioner, right? So that signal conditioner, it will be reads that signal conditioner input characteristics shall be compatible with the output characteristics of sensor, right? बघा, so signal conditioner काय करतोय? Signal conditioner, it will be bring the signal from the sensing element, म्हणजे sensor पासून येणारा signal जो आहे तो bring कर, right? While interfacing that sensor and the signal conditioner, we want to understand or we require the characteristics of output of the sensor and input of the interface circuit, or it may be signal conditioner. It will be same. Then we are able to interface, right? तर आपण interface करू शकतो ना? सेन्सरचा आउटपुट आणि जो काही सिग्नल मिळणार आहे, इलेक्ट्रॉनिक सर्किटरी आपण त्याला इंटरफेस करणार आहे, त्या दोन्हीचं सेन्सरचा आउटपुट आणि सिग्नल कंडिशनरचे इनपुट सेम असल्यानंतरच आपण इंटरफेस करणार, राइट? सो अ सिग्नल कंडिशनर इनपुट कॅरेक्टरिस्टिक्स shall be compatible to the output characteristics of the sensor. Okay, shall be compatible with the output characteristics of the sensor, while its output should generate voltage for ease of interfacing with analog to digital converter, or it may be ADC, right? Analog to digital converter, or it may be other type of load. So that means signal conditioner having an input characteristics which is same as that of output characteristics of sensor. Then we are able to interface each other. So this is electronic circuitry, some of the required to interface that sensor element or sensing element to the microcontroller, or it may be to the analog to digital converter. It is called as load device. So that interfacing circuitry or electronic circuitry having some of the input characteristics which is similar to the output characteristics of sensing element. Sensing element ची जी काय output characteristics असेल त्याच्याशी same पाहिजे, there we are being interface, right? Now the front end of the signal conditioner depends on types of the sensor output electric characteristics, right? So we people already know sensor is nothing but one type of device which can convert non-electrical energy into electrical. So output obtained from the sensor, it is in the form of electrical. So we people front end of the signal conditioner and the input characteristics of signal conditioner, it is depends upon sensor output electric characteristics. जे sensor output आहे त्याचाच इंटरफेसिंग आपण म्हणजे सेम कॅरेक्टरिस्टिक्स इलेक्ट्रॉनिक डिवाइस ऑफ सिग्नल कंडिशनिंग वे आर इंटरफेस, राइट? सपोज सेंसर इट विल बी गिव्स आउटपुट इन द फॉर्म ऑफ voltage. So we require interfacing signal conditioning, again input characteristics of voltage. Okay, जे सिग्नल कंडिशनिंग जे किंवा इंटरफेस सर्किट यूज करणार आहे त्याची इनपुट कॅरेक्टरिस्टिक्स काय पाहिजे? Voltage. It will be able to compatible with that of voltage, or it will be able to join with that of output of the element. So there are 5 basic type of sensor output. 5 basic type मध्ये sensor output असेल. So output properties, In the first one is nothing but output of the sensor. It is in the form of voltage. Output of the sensor it is in the form of current. Output it is in the form of resistive. Output it is in the form of capacitive and inductive. Right. So these are the 5 basic types of output characteristics. That means sensor output it is in the form of 5 formats: voltage, current, resistance or resistive, capacitive and inductive. So that we require interfacing circuitry depends upon that output. Whether the output is in the form of resistive, so interfacing circuitry input characteristics it should also be resistive, right? Resistive पाहिजे जर आउटपुट व्होल्टेजच्या फॉर्म मध्ये असेल जे इंटरफेस करणारा डिव्हाइस आहे त्याची कॅरेक्टरिस्टिक्स इनपुट कॅरेक्टरिस्टिक्स इट इज इन द फॉर्म ऑफ voltage. There we are not able to interface with the output of sensor. It is in the form of voltage, and we are interfacing resistive input characteristics. Okay, so there are depends upon types of output of sensing element. We are interfacing some electronic circuitry. Right? We are interfacing some of the electronic circuitry. Selecting the appropriate input stage of the signal conditioner is essential for the optimal data collection. Right? Notice है बघा notice training and placement office, suspension of candidates, training and placement office conducted campus recruitment training CRT for third year from 5th April to 9th April 2022, right? So it was told before start of training to those students. CRT 1 झालेलं आहे ना? झालेली नोटीस आहे. Training and placement office conducted campus recruitment training for third year from 5th April to conducted म्हटले त्याच्यामध्ये conducted training for third year from 5th April to 9th April 2022. It was told before start of training to those students that whoever will remain absent for this training session will be suspended and such a student will not be considered for any campus trial. सांगितलं होतं? Okay. Accordingly, details of student those were absent for all the training session are attached. These students will not be considered for upcoming campus drive. If anyone has a genuine reason, then such a candidate can approach respective HOD, and HOD recommended if any after discussion with parent of the candidate. So list is given those who are absent for the CRT first. In that Bodke Prajakta. Okay. So if you have any genuine reason, after that Dhotre Ashwini, Shirsagar, Renuka, Padavale Prajakta, Adatra Omkar, Bedge Jyotiram, Desai Kuldeep, Gaikwad Vikrant, Kiram Shusharan, Kolge Abhijit, Bodke Prajakta, Shiraskar Prashant. So these are the list. ते स्टुडंट असतील signal conditioner. It is serves as a very important role. Okay, so selecting the appropriate input stage of the signal conditioner is essential for the optimal data collection from the sensor. So to collect the data from the sensor, signal conditioner or selecting appropriate type of signal conditioner, it is very important. Okay, and it will serve the two function, that is it will bring the signal from the sensing element and it is fed to the load devices, or it may be analog to digital converter. Okay, now there are 5 types of output. There are 5 types of output obtained from the sensor element that we have already discussed. That is output obtained from the sensor element. It is in the form of electrical. One is voltage, current, resistive, inductive, and capacitive. So see, there are sensor type is given, sensor impedance is given, and signal conditioner front stage is given. So this chart, it will be shown that the sensor type. Again, what about impedance of the sensor? Sensor output चा impedance काय असेल, and front stage of the signal conditioner. जो आपण इंटरफेस करणार आहे सिग्नल कंडिशनर, त्याची फ्रंट स्टेज ची कॅरेक्टरिस्टिक्स काय असतात. सी voltage out, that means sensor whose output it is in the form of voltage. Getting sensor output it is in the form of voltage. So sensor impedance, that is R, it is very low, or resistance it is very low, and the signal conditioner, which signal conditioner it can be interfaced with that output of sensor, it is nothing but high input resistance amplifier, right? बघा, जर सेन्सरचा आउटपुट it is in the form of voltage असेल, we want to interface some of the signal conditioning circuitry to output of the sensor. So some of the characteristics is given. If the output it is in the form of voltage out, then that sensor element or sensing element having a very low resistance, or it may be very low resistance in there. Then we want to interface the electronic circuitry to output of that sensor. It is in the form of high input resistance amplifier, right? So बघा, याचं व्होल्टेज मिळणार आहे, याची काहीतरी amplitude असेल किंवा याचा एक सिग्नल मिळेल, right? So output signal it is in the form of voltage, काहीतरी amplitude असेल, suppose here it is Vm amplitude. We want to interface with signal conditioner that output having a high input resistance amplifier. Amplifier interface करणार आपण, low level signal it can be converted to high level, and amplifier having a high input resistance. So this is the interfacing of that signal conditioner with that type of sensing element output. जर सेन्सिंग एलिमेंटचा आउटपुट व्होल्टेज असेल तर ते इंटरफेसिंग सर्किट आपल्याला काय करावं लागेल, कनेक्ट करावं. सिमिलरली इफ द करंट आउट is here, at that situation current output of the sensor is there at that situation. So here we want to connect one resistor and one capacitor, that means this is the filter circuit. So very high complex, then high input impedance amplifier or low input resistance circuit, that is ampere meter it can be. See, high input impedance amplifier कनेक्ट करायचं आहे अभी काय high input impedance or low input resistance circuit ideal amplifier किंवा ideal voltmeter ideal ammeter किंवा करंट सोर्स आपण म्हणतो ideal voltmeter किंवा त्याला व्होल्टेज सोर्स राइट सो इट इज having an high input resistance amplifier and low input resistance circuit that is ampere that means it will read the maximum amount of current we want to interface that signal conditioning to sensor output it in the form of current output form. Now next one, if the output it is in the form of resistance, variable resistance, output it is in the form of variable resistance. So sensor impedance it is nothing but variable resistance, and we want to interface that signal conditioner resistance to the voltage converter. Resistance to the voltage converter it is called as we want to interface here ohm meter, right? Ohm meter that is resistance to voltage converter. After that, capacitive output is there, that is output of the sensor it is in the form of capacitive. Then complex filter circuit is there, and then capacitance to voltage converter required, that is capacitance meter it can be. Capacitance conversion voltage मध्ये that means capacitance meter it can be required, it will convert capacitance to voltage. Right, then inductive output of the sensor is there, sensor output obtained it is nothing but it is the variable inductance. Complex circuit will be required, variable inductance in series with resistance and in parallel with capacitance. So filter circuit it can be required, and here interfacing to that output we require signal conditioner, that is inductance meter. We require inductance meter. Okay, so see, these are the five output of the sensor, and which device can be interfaced. So these are the signal conditioner front stage. Signal conditioner front stage काय पाहिजे? First one साठी high input impedance amplifier required. Second one साठी high input impedance amplifier or maybe low input resistance circuit, ampere meter, resistance to voltage converter, capacitance to voltage converter, inductance to voltage converter or inductive meter, capacitive. These are the signal conditioning depends upon output of the output sensing element or it may be sensor, depends upon sensing element or sensor च्या output वरती depends असेल. Okay, so see input characteristics it is the first one point. पहिला point आहे input characteristics. Okay, so first one point is that input characteristics of sensing element, input characteristics of interface device. Interface device ना sensing element च्या आउटपुटला जे काही इंटरफेस करतोय त्याची इनपुट कॅरेक्टरिस्टिक्स काय आहे. So input characteristics, the input part of the signal conditioner may be specified through several standard parameters. So there are some of the standard parameters there. Some standard parameter is given and depends upon that standard parameter, the input characteristics of signal conditioner can be defined. So in that first one, these are useful for calculating how accurately the circuit can process the sensor output signal and what would be the circuit contribution to the total error bus. Right? See, these input characteristics it is important for calculating how accurately that circuit it will be processed to that of sensor output. Sensor च्या output ला process करावे लागणार आहे. Suppose low level signal असेल तर high level करावं. So if which types of circuit, that means if we use amplifier it will convert low level to high level, right? So how it will be accurately processed? It will be depends upon its input characteristics. Input characteristics serve that function. It is useful for calculating how accurately the circuit can process the sensor output signal and what would be the circuit contribution. आणि त्या सर्किटचं contribution काय आहे to reduce the error or to minimize the error. Right? म्हणजे कमीत कमी error कसा होईल. So how much contribution of that circuit in that system, so to reduce the total error budget, okay, total error किंवा error reduce करण्यासाठी त्याचं काय contribution असतं. So this will be understood by using input characteristics. The input impedance shows by how much the circuit loads the sensor at a different frequency. Okay, so input impedance, you know, impedance formula Z is equals to V divided by I. In that, this impedance shows that how much circuit loads the sensor at different frequency. Okay, at different frequency, impedance defines that how much sensor it will be loads with different frequency, that is Z is equals to V divided by I, where V and I are the complex notation for the voltage and current across the input impedance. Right? So V, it is nothing but complex voltage and I is nothing but complex current. For example, here this example is given. If input of the signal conditioner is modeled as a parallel connection of the input resistance R and input capacitance C, the complex input impedance may be represented as. जर input characteristics किंवा input impedance of signal conditioner, it is modeled such that in the parallel combination of resistance and capacitor, resistance आणि capacitor चं parallel combination असेल, resistance okay. See that signal conditioner, if it is modeled in the form of R, it is in parallel with capacitor C. Okay, signal conditioner हा सेन्सर आहे त्याचा आउटपुटला आपण हे सिग्नल कंडिशनर काय करतो इंटरफेस करतो. If it is modeled like this, resistance is in parallel with capacitor, here it is we obtain the Vout. At that situation, impedance of that circuit is equals to Z is equals to R divided by 1 plus J omega RC. Okay, so this is the complex notation. So R resistance divided by 1 plus J omega into RC. This is the complex notation. So we got the output of the signal conditioner again voltage. So here omega is nothing but circular frequency and J is equals to under root of -1. You people already know this value is the imaginary unity. So above formula suggests that the input impedance is the function of signal frequency. Okay, so this omega it is nothing but circular frequency. Omega it is nothing but circular frequency, and from that equation it is represented that or suggested that the input impedance it is a function of frequency, right? Signal च्या frequency चे काय असेल function असेल. With increasing the signal rate of change, the input impedance becomes lower, right? See 1 plus j omega that means sample frequency or circular frequency if it is increases. Okay, याची व्हॅल्यू जर increase झाली automatically Z काय होईल decrease होईल ना. So that means it will be lower. So if sampler frequency or circular frequency it can be increases and depends upon this equation it will be shows that inverse proportion okay. On the other hand, at the very low frequency a circuit having a relatively low input capacitance, the frequency minimum value. So according to equation, capacitive reactance Xc is equals to 1/2 pi Fc. If very low frequency, low input capacitance and resistance are has an input impedance that is almost equal to the input resistance. Okay, it is having an input impedance which is almost equal to the input resistance, that is Z is equals to R, and relatively low. Here means that the reactive power of the above equation becomes negligibly small. That is the following equation it will shows RC into 1/2 meg. RC into 1/2 meg. Now this product of RC is called as time constant in RC network. RC networks are time constant. RC is nothing but time constant, and it is represented by tau, that is measured in the seconds. So whenever the input impedance of the circuit, is considered, the output impedance of the sensor must be taken into account. The interfacing circuits are input impedance if we are considering. So at that situation, we are able to consider the output of the sensor also. Output impedance of the sensor is to be taken into account for very obvious reason. When the sensor is attached, the impedance are connected in pairs. Okay. Now the sensor interfacing circuit attached at that situation, the impedance of that means Z is equal to R. That means it will act as the same impedance, right? And it is connected in parallel. It is connected in parallel. So see, this diagram shows that the input impedance which is connected in parallel, here it is Z out, here it is Z in, here it is circuit. So figure shows an equivalent circuit of voltage generating sensor. Voltage generate करना जो का sensor है त्याचं equivalent circuit show केलेला आहे figure मध्ये. The signal conditioner front end, signal conditioner चं front end is nothing but output end of the sensor. So this compare the sensor output, right? It will compare with that of sensor output and Z out and the circuit input Z in impedance. We use here scalar notation. So see Z out and then it is Z in. So this is nothing but one is nothing but Z out is nothing but output of the sensor. Okay, output impedance of the sensor, and Z is nothing but input impedance of the interfacing circuit. Interfacing circuit, the circuit's input impedance. Okay, so output signal from a sensor it is represented by a voltage source. Output signal of that sensor it is represented by a voltage source E. So that means it is the voltage output type of sensor. We want to take into account Z out of the sensor and Z in of the interface circuit, right? Interface circuit is a Z in, so which is connected in series with the output impedance Z out. So note that an ideal voltage source E by definition has a zero internal impedance. So in case of ideal voltage source, it is having a zero internal impedance. Ideal voltage source माहिती है ना? Ideal voltage source. बॅटरी जी आहे बॅटरी आयडियल व्होल्टेज सोर्स आहे का प्रॅक्टिकल आहे practical. Ideal voltage source having an zero its internal impedance. मग बॅटरीचा प्रॅक्टिकल असेल, आयडियल व्होल्टेज सोर्सचा 0 असतो, प्रॅक्टिकल व्होल्टेज सोर्स इट इज हॅविंग अन समवॉट इंटरनल इम्पिडन्स. तो आपण व्होल्टेजच्या बाहेर रिप्रेझेंट करतो, बरोबर ना. आयडियल आणि प्रॅक्टिकल, सो वी आर रिप्रेझेंटिंग सपोज दिस इज द व्होल्टेज सोर्स, वी आर रिप्रेझेंटिंग दिस वन ऑफ द इम्पिडन्स ऑफ रेजिस्टर. त्याच्या बाहेर रिप्रेझेंट करतो. बॅटरी मध्ये इनपुट इम्पिडन्स किंवा इंटरनल इम्पिडन्स कोणता असतो? बॅटरी मध्ये इनपुट इम्पिडन्स किंवा इंटरनल इम्पिडन्स रेजिस्टन्स जो काय असेल कुठं असतो? आयडियल आहे का प्रॅक्टिकल आहे? आता आयडियल आयडियल व्होल्टेज सोर्स इट इज नथिंग बट इट इज हॅविंग अ झिरो इंटरनल इम्पिडन्स. त्याचा इंटरनल इम्पिडन्स झिरो. बॅटरी आयडियल आहे का प्रॅक्टिकल आहे? आयडियल. प्रॅक्टिकल आहे. प्रॅक्टिकल व्होल्टेज सोर्स हॅविंग अ समवॉट इंटरनल इम्पिडन्स. मग कुठं असतो बॅटरी मध्ये? कुठं असतो? माहिती झालंय तुम्हाला, फक्त तुमचं लक्ष नाही. इलेक्ट्रोलायसिस प्रोसेस माहिती आहे? इलेक्ट्रोलायसिस नाही, इलेक्ट्रोलाइट माहिती आहे? इलेक्ट्रोलायसिस प्रोसेस होतं ते इलेक्ट्रोलायसिस प्रोसेस मध्ये वन एनोड वन कॅथोड कुठं असतो मग इंटरनल इम्पिडन्स? काय माहिती डायग्राम माहिती आहे फक्त. So here one is act as anode, one is act as a cathode, or positive electrode and negative electrode. जर NaCl ची reaction consider करत असाल, Na it can be deposited to the negative electrode, Cl it can be deposited to the positive electrode. So there is a ion exchange. So at that situation there is a NaCl solution is there. असतं का? Now that solution, or it is also called as electrolyte, this will act as an internal impedance or internal resistance. That's the kind resistance असेल. So this solution, or we can call it as an electrolyte, it will be act as a resistance in the battery. So it is nothing but internal resistance of the battery. Battery is the internal resistance. So ideal condition la that internal resistance it will be 0. Its real impedance is modeled by Z out, and if the impedance is low, especially its resistance part over the entire frequency. Okay, so according to previous equation, Z is equals to R divided by 1 plus J omega RC. J omega RC. And if the impedance is low, at that situation, resistance part overrides entire frequency range, and the sensor and signal conditioner reactive component like capacitive or inductive can be safely ignored. So if the impedance is low, the resistive part over the entire frequency range, so R part असेल, it will over its frequency range. And the sensor and signal conditioner reactive component like inductive and capacitive component, so it can be safely ignored. So however, if the sensor output impedance has a sizable value, it cannot be ignored. Sensor output impedance असेल, if it is in size with that of input impedance of the circuitry, then it cannot be ignored. ते ignore केले जात नाही. So this is related to input characteristics. Again, input stage of the signal conditioner. Here represented signal conditioner. Signal conditioner, that means we are interfacing the output of the sensor. Sensor चा output ला represent करतो. So it is having an impedance characteristics किंवा diagram मध्ये impedance Zin आणि Zout. So similarly, V is nothing but input voltage to the interface circuitry. At the same time, Vout is nothing but output voltage of the sensor element or sensing element. Sensing element's output voltage, we are interfacing that. So at that situation, this Zin can be represented here, and to interface that, there are some of the current source it can be used. Here this is the voltage source, V0, EM. So diagram up to EM, and here is I1 to IM, that means current source which is connected. आपण याला compensation करतो, right? To get that required value, we are doing the compensation of current compensation. Compensation माहिती आहे? Power system मध्ये compensation आहे. Fact नाही. Fact devices आपण compensation करतो, reactive power compensation किंवा current compensation, voltage compensation. म्हणजे to meet that value or to meet the power quality, जी काय पॉवर ड्रॉप होते किंवा व्होल्टेज ड्रॉप होते ती व्हॅल्यू मीट करण्यासाठी आपण एक्स्ट्रा व्होल्टेज कंपन्सेशन म्हणजे त्याच्यामध्ये ऍड करतो. व्होल्टेज त्याला करंट कंपन्सेशन किंवा व्होल्टेज कंपन्सेशन. सिमिलरली वी आर compensating some of the current source to meet that value. Current source काय करतात compensate करतात. See, the more detailed equivalent circuit of the input property of the signal conditioner for instant and amplifier can be shown in this figure. So the circuit is modeled by the input impedance Zin and several generators producing interfacing signal. The generators are used to produce the interfacing signals. They represent the voltage and current that are spuriously generated by the circuit itself or picked up from the various external source, even if the sensor generates no signal. Okay, जे काय व्होल्टेज सोर्स आणि करंट सोर्स आपण काय केले अटॅच केले कंपन्सेट केले. If the sensor will not generate any one of the output or low level output, compensate that value, we require some of the voltage generator and some of the current generator. So current generator it can be connected in parallel, voltage generator it can be connected in series. Voltage generator series मध्ये connect केले. So these undesirable voltage and current may possess substantial problem if not handled properly. Right? If is collected voltage or the compensated current or voltage, if it is not handled properly, then it will make some of the problem in that circuit. So beside many such noise generators are temperature dependent. So याच्यावर काय होतं noise generate होऊ शकतो. So some of the noise it should be increase the temperature, that means it depends upon temperature. काही generator असते याच्यामध्ये because of unequal value or unequal distribution it will generate some of the noise. Noise मुळे काय होईल परत सर्किट मध्ये temperature increase होण्याची शक्यता आहे. So that means if it is not handled properly, it will make some of the problems. Okay. See, voltage E0, the E0 voltage of the EM voltage E0 is nearly constant and called as the input offset voltage. This is the next question. So E0 is constant. त्याच्यामधला जो काही E0 असेल it is constant and it is called as input offset voltage. If the input terminal of the signal conditioner are shorted together, signal conditioner is the input terminal short में zero input signal, that voltage is simulate the presence of virtual DC voltage input signal having value is zero. So it should be noted that the offset voltage source, is connected in series. With the input and its resulting error is independent of the output impedance. The resulting error is independent of output impedance of the sensor or its signal. That is, the offset voltage has an additive nature. Offset voltage additive nature असेल. So the input bias current I0 is also generated internally by the front stage or introduced from some external interfacing source such as circuit board leakage current. Okay, circuit board leakage current. So these are the related to input characteristics of signal conditioning. Signal conditioning ची input characteristics कशी पाहिजे. For example, it can be given. एक example दिलं होतं आणि त्याच्यानुसार त्याचे expression, that is input characteristics of the signal conditioning. आपण ज्या पहिल्या characteristics बघितल्या, these are the characteristics of sensor, right? Sensor ची characteristics. So these are the input characteristics of signal conditioner or interfacing device. जे interface करणारा device त्याची input characteristics काय पाहिजे, depends upon output of the sensor. Sensor च्या output वरती काय आहे, depends, right? Getting काय doubt आहे तुम्हाला? डाउट आहे काय तुम्हाला? Next one point is that amplifier. Amplifier. So you people already know the amplifier. If the signal it is having a low level, we are using amplifier to convert that signal into high level. So amplifier म्हणजे आपला जो काय स्पीकर किंवा काय म्हणतो आपण त्याला, मायक्रोफोन आणि स्पीकर ना, त्याच्यामध्ये amplifier असेल. So amplifier circuit you people already know because you have already studied in EDC. EDC मध्ये झालेलं आहे amplifier. So again there are two types: positive feedback, negative feedback. Feedback amplifier, positive feedback amplifier, negative feedback amplifier. So amplifier is a part of signal conditioner. Amplifier or signal conditioner चा part आहे. There are several standard configuration of the signal conditioner, configuration of the amplifier that might be useful for amplifying low level signal. So it might be useful for amplifying low level signal or converting low level signal into high level signal. So this amplifier may be built of discrete component, so such as semiconductor, resistor, capacitor and inductor. So this is made up of semiconductor, then resistor, capacitor and inductor. So amplifier are frequently composed of standard building block such as op-amp, operational amplifier. So operational amplifier or op-amp that are augmented with various discrete components. Right? So these are the discrete components like semiconductor, resistor, capacitor and inductor. By augmenting these different discrete component, we composed one of the standard building block or op-amp by composing this discrete component like semiconductor, resistor, inductor or capacitor. An amplifier also is an impedance matching device. Okay, आपण आता characteristics बघितली त्याची, त्याच्यामध्ये impedance होता, impedance equality comes into picture. So amplifier also is an impedance matching device. Amplifier जे आहे ते impedance match करेल. This will be matched with the impedance of output impedance of the sensing element or the sensor. So an enhancer of the signal to noise ratio, it will enhance the signal to noise ratio. A frequency filter filter, and an isolator between the sensor and rest of the circuit. The amplifier serves as a different function. It will be used as the matching the impedance. Again, it will be used as a frequency filter. That means filtering signal or काही error असेल ते filter करून जाईल त्याच्यानंतर it will act as an isolator also. Okay, so that means it will used for protection purpose of the sensor also. Isolator म्हणजे isolate करणं, faulty condition मध्ये काय करायचं पूर्ण isolate करून करायचं सुद्धा it will be served as a most important function, that is amplifier, frequency filter, isolator between the sensor and rest of the circuit. The sensor ला other interfacing circuitry पासून काय करू शकते isolate करू शकते if any fault it will be. So operational amplifier basic block diagram you people already know. Operational amplifier ची basic block diagram कशी असते? कशी असते? amplifier ची block diagram माहिती? असते ना बाकीचे एलिमेंट इंटिग्रेट करतो आपण डिस्क्रीट एलिमेंट लाईक रेजिस्टर इंडक्टर त्याच्यावर त्याचे टाइप आहे सपोर्ट इनपुट रेजिस्टर्स असा टाइप केलेला राइट नाउ ऑपरेशनल एम्प्लीफायर अगेन आउटपुटचा फीडबॅक आपण देतो तर फीडबॅक निगेटिव्ह पॉझिटिव्ह असेल देयर आर टू टाइप्स निगेटिव्ह फीडबॅक एम्प्लीफायर पॉझिटिव्ह फीडबॅक एम्प्लीफायर राइट so one of the principal building blocks for amplifier is the so called operational amplifier or op-amp, so which is either an integrated or monolithic or hybrid. So discrete components integrate केला असेल it's called a hybrid combination of monolithic and discrete part. monolithic म्हणजे एकतर only amplifier असेल op-amp त्याला आपण discrete component कनेक्ट नाही करणार. This is also one of the amplifier. If we are using the hybrid amplifier, that means we combine with monolithic part and discrete part. Discrete part of discrete component is nothing but resistor असेल त्याच्यामध्ये inductor असेल capacitor असेल so this element असते right. So an integrated op-amp contains hundreds of transistors right. So integrated op-amp it may contain hundreds of transistors, diodes as well as resistors and capacitors. Consist of this integrated component. An analog circuit designer by arranging around the op-amp discrete component that is resistor, capacitor and inductor may create endless number of useful circuits. Okay. It will create number of useful circuit, not only amplifier but also many other circuit as well. So जर आपण याचे इंटिग्रेशन केलं not only amplifier it will be created, many other circuit it is also created. So op-amps are also used as a cell in custom made integrated circuits, analog or mixed technology. Op-amp it is also used as a cell in custom made integrated circuit. Custom made is nothing but customly it will produce a mixed technology or it may be analog technology. Different technologies are used for custom made integrated equipment use for आपण काय करू शकतो op-amp we can use as a cell also. A custom circuit it is called as application specific integrated circuit or ASIC for short. So here the block diagram of that amplifier. So this is the block or it may be to contain different component. This block shows that one of the amplifier there is one of the negative terminal, one of the positive terminal. Okay, so here reference potential ground, one of the voltage can be provided that here it is not another one component it can be used. The integrated discrete component is resistor, capacitance. So this picture shows that the block diagram of amplifier. That's the block diagram. So therefore it operates under open loop condition. As you know, feedback it will act as a open loop condition and open loop gain, that is an open loop gain AOL of an op-amp is always specified but is not a very stable parameter. Okay. Open loop gain जो है always specify केलेला असेल but it is not a stable parameter. Its frequency depends upon approximated by graph. The graph वरती frequency depends असेल. So the open loop gain changes with the load resistance, temperature and the power fluctuation. म्हणजे काय open loop gain असेल operational amplifier चं, it can change with the resistance, it can change with the temperature and also it is change with the power supply fluctuation. म्हणजे हा जो काय power supply केलेला आहे त्याच्या fluctuation वरती पण gain change होईल. Resistance reset केला तरी पण gain change होईल. As well as if the temperature of that circuit or it may be equipment it will be increases, then also gain it will be changes. आपण gain represent करतो. So here voltage can be applied. This graph it will be shown that frequency versus gain. Frequency versus gain characteristics. At how much frequency, what is the gain obtained, that is open loop gain. It will show some of the graph. Up to that frequency, here it is 10 raised to 3 frequency. Up to 10 raised to 3 frequency, 1000 hertz frequency or 1 kilohertz frequency. Up to that, the open loop gain remains constant, and after that, it start decreasing. And at one point, here it is 10 raised to 9, 5, 6, 7, at 10 raised to 10, the frequency at 10 raised to 10 frequency, the open loop gain it is nearly equal to 0. Gain it is nearly equal to 0. So this is the graph of the op-amp or operational amplifier, and this graph gain it will be changes with some parameter like temperature, resistor as well as power supply change. Power supply change or it may be power supply fluctuation. Okay, so okay, so this operational amplifier or op-amp, that is building block. As a good operational amplifier has the following property. Operational amplifier, it is good, it is having some of the properties requirement. So two input, one is inverting and another one is non-inverting. The दोन input पाहिजे त्याला, एक positive असते एक negative, that is one is inverting and another one is non-inverting. High input resistance, operational amplifier चा input resistance काय पाहिजे? High पाहिजे, so it is one of the property. Low output resistance of that is equal to low. Then ability to drive capacitive load without becoming unstable, right? So that operational amplifier it is good when it is able to drive a capacitive load, okay, without instability. So that means if the capacitive load is there, its operation it may be stable. Okay. So there should be not instability. Low input offset voltage, that is E0. That voltage it is nothing but low input offset voltage. Low input bias current, I0 should be low. Very high open loop gain. So open loop gain जो है वो very high पाहिजे. Then high common mode rejection ratio, that is CMRR, common mode rejection ratio should be high. Then low intrinsic noise, intrinsic nothing but external noise should be low. Then broad operating frequency range, that means it will able to operate the broad frequency range or maximum frequency range. Then low sensitivity to the variation in the power supply voltage. जर power supply voltage मध्ये variation झालं तर it is very low sensitive to the variation. म्हणजे त्याच्या आउटपुट गेन वरती मॅक्सिमम इफेक्ट नाही पडणार, right? So it is low sensitivity to variation in the power supply voltage. Power supply voltage काय झालं त्याची sensitivity low पाहिजे, so low sensitivity पाहिजे and high environmental stability of its own characteristics. So it is environmental stable, or maybe its environmental stability should be high to its own characteristics. So these are some of the properties of good operational amplifier or good op-amp. Okay, so this is related to op-amp. All of you understood? Operational amplifier. So this is also one of the signal conditioning device. Which आपण interface करणार जे device है. It is one of the operational amplifier, right? So remaining part we will discuss in the next lecture. Yeah. I sure